This is going to be my demo for targets 9A, B, and C. For 9A, we're going to make a state diagram. For 9B, we're going to do the next state table. And 9C, we're going to implement using logic circuits. So the finite state machine I chose to implement today is going to be an elevator controller with 4 floors. It can only go, or it can go to any floor, but of course by going through the intermediate floors before reaching the final destination. So moving on to the state diagram, there's going to be 4 floors as mentioned previously. G is going to be the binary number for 0, and I did this so that the floor can match the binary number equivalent. So if you're on the ground level floor and the inputs are 0, 0, you will stay at the ground floor. And this is going to be the same for each of these states. If you're on 1 and you have the inputs for 1, you're going to stay at 1, and then 2, and then 3. And then, as mentioned in the description, we can't go from the ground level to 2 or 2, 3. And then this is also the same for real life. You can't just like skip floors. So for 1, 2, or 3, we would have to go through 1. And I just wrote 1 arrow going this way, and then the binary, or not the binary, but the decimal number for all these floors, just for simplicity, and to just keep the state diagram a little cleaner. So if we're at 1, we can stay at 1. We can go to the ground floor, or we can move on and go on to 2 or 3. If we're at 2, we can go back to 1, or we could go back to 0. Either way, we're going here. And we can go to 3. Now, if we're at 3, we can stay there, or the only other option is to go to either second floor, first floor, or ground level. So taking this state diagram, we will be moving on to the next state table. So for this finite state machine, I chose to use JK flip-flops, and that is for all of the do not care conditions. I knew that with 4 states and 4 different K-maps, it was gonna get pretty, I was gonna get out lengthy equation. So I decided to go with the JK flip-flop. Even though I'm gonna have more equations, I would rather have it be there than use a D flip-flop or a T flip-flop. So that being said, we'll first look at our current column and then move on past those columns. So our Q1 and Q0 here are going to be where we're at. And we can see, as mentioned before, these 4 were on the ground level, these 4 were on the first level, these 4 were on the second, and then third. F1 and F0 are going to be the inputs. So if we're on the ground level floor and we input that we want to go to the ground level floor, the next floor we're going to be at is the ground floor. And that is going to be this column, the next column. And because the next column is going to be the corresponding binary count to that floor, I just have Q1 and Q0 here. So moving on, if we're on level 1, or if we're on ground floor and we want to get to 1, if we're on the ground floor and we have inputs to go to 1, we will go to 1. And as mentioned previously, you cannot skip any levels. So the rest of these are also going to be going to 1. Moving on to floor 1, if we're at floor 1 and we want to go to floor 0, or if we're at floor 1 and we have inputs to go to 0, we will go to 0. If we're at floor 1 and have inputs to go to 1, we will stay there. And then to go up, we will be going to floor 2. The same goes for floor 3. Floor 3, we only have 2 options. We can either go down a level or we can stay. Next, we're going to be moving on to our flip-flop inputs, and it's going to be what inputs we need to accomplish what we need to happen to get to the next spot. And for that, we're going to need this little cheat sheet right here. So for J1, K1, we're going to be looking at Q1 and Q1 for current and next. I'm not going to go through all of them. I'm just going to go through like maybe one in each state. So we have J1. We're going to look at the first one. So our first one's going to be 0, and then our 0. We go to this little cheat sheet. We know that 0, 0 is going to be 0x. That's why I have a 0x there. For 0, 1, or for this column, this row, we have 0, and then 0 again, 0x, and then if we want to do any of these, we would be looking at Q0 and Q0. So now that I have this next state table filled out, we can move on to the K-maps. From the K-maps, we can derive the Boolean equations. So I've already done those. This is going to be the K-map for J1. And again, the do not care conditions are helping here. They're going to be helping everywhere. But this is going to be the K-map for K1. We have the wraparounds. Yeah. J sub 0 got a little messy, but we're here. And K sub 0 again got a little messy, but we're here. So we're gonna move on to 9C, which I've already done here. So we can go ahead and follow some of these. So we have J1. And from those K-maps, we found that the equation for J1 is gonna be Q0 ANDed with F1. So we can find Q0 is going to be right here. And follow here, 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 here. This is an AND gate. And then you can follow F1. And that goes straight into J1. And yeah, this is going to be the logic circuit for this FSM. And then, of course, we have our outputs.